Good evening, everybody, and welcome to the October meeting of the BTS. For tonight, we've got Christoph Eberle, who's going to do a presentation on the current state of the BTS ICE specification on sustainability.
Hi, good evening, everyone, and welcome to the BTS evening meeting. Also from my side, it's on our BTS ICE specification 4th edition for tunneling, not on sustainability. I have to correct you about that. I think every tunneling presentation should start with a nice tunneling picture. What you see here is a lovely TBM. This is Dorothy, by the way, who broke through at Long Itchicken Wood at the 22nd of July this year. I think this is the first one who broke through at HS2 Area North. Enjoy. It's a lovely TBM, isn't it? Great success for the team. Congratulations. Anyway, our agenda tonight, we'll start with a safety moment. Then I'll talk a bit about the positioning of our BTS specification as our industry's business card. Then some words about the new content which we developed over the last couple of years and where it sits in the wider sustainability context. Also, I want to then reach out to our industry collaborators and show what level of participation we achieved when pulling the specification together. And last not least, route to publication, where will it all end, and further opportunities for engagement on the specification. But let's just move to the safety moment, which is in this case a bit of a personal thing as well. What you see top left-hand corner is a lovely 3D model, typical of the major projects which we are undertaking at the moment in UK and abroad. It's a quasi-standard, I'd say. It looks lovely, it's colorful, it's a great sales pitch, and it's representing all elements of the design in a precise position in absolute coordinates. And here we go, that's where the problems actually start, because as you know, if you start a design, you're not positioning your elements necessarily in absolute coordinates. You might have a setting out point for a shaft in easting and northing, fine, but then you want to have your lining offset by X millimeters from your primary lining. You want this then positioned here relative to that wall, but you can't really capture that in a 3D model. Because it can't differentiate between absolute coordinates and relative coordinates. It simply does not have this intelligence. So you need to think closely about tolerance, about the positioning allowance for each of these elements you're putting in, and about the dimensional allowance, which is inherent to that element. This leads to a nice game of spot the clash when you start designing the thing in earnest, and especially if you start building the thing. Just some examples. You have dependencies in a tunnel, in a rail tunnel, relative to the rail alignment, such as the second stage concrete, or you have tunnel alignment dependencies as well, which means basically the rail alignment in itself needs to first reposition relative to the tunnel alignment. If you then put your second stage concrete into exactly the same level which you have in your 3D model, you screwed up. It won't work. It's wrong. So the lesson for learning here is basically your design needs to be tolerance conscious, and the accurate tolerances of construction and dimensions must not compromise your design and how to build it. All stakeholders must be involved. You should really engage with all the people who have a stake in the project early on and address any thoughts about tolerances and constructability workshops. I have a nice sort of last observation here, and which is simple designs lead to simple mistakes, complex designs lead to complex mistakes. So my personal preference is to keep it as simple as possible and to stick to the KISS principle. Now, building on success, going forward to our actual specification, and a much overlooked anniversary is that it's 25 years of the BTS ICE specification for tunneling this year, because we started in 1997 with the BTS ICE model specification for tunneling. And as you see on the timeline, we actually have come a long way since then, and as an industry have achieved plenty. Going through the timeline, here are key construction mega projects in the UK, Channel Tunnel Rail Link, Crossrail starting in 2009, Victoria Station upgrade, Northern Line extension, Bank Station upgrade, Tideway, and then we're already coming to the present where the construction of High Speed 2 has started 2 years ago. COVID or no COVID, we went ahead. As you see, the BTS specification has developed along this timeline. It has grown, matured, and has captured the findings and the best practice, which have been developed along the way. Coming to the bigger picture of the global rule setters and where do we sit and where do we stand with our BTS specification, where does it actually fit in the global context of tunnel design? Several organizations beside the BTS produce reference documents, just to name a few, the CN, the AASHTO, ACI, we have the AFTES in France, we have DAUB in Germany as our counterparts, and we have the industry representations such as COB and STUFA, who also produce their guidelines. We have also, last but simply really not least, the ITA, which serves as a common forum for all of us to exchange our ideas and pick up new developments and new theories in tunneling. Where do we sit in that? What's our role? And obviously this is a bit of a personal take, but the way I see it, the BTS is our link between these various standard setters and developing bodies and the UK tunneling industry. We as a BTS, as an organization, and as our members, we monitor guidance and evaluate best practice as it evolves, which we then in turn sort of distill and evaluate and consolidate into our BTS specification. The important aspect of this approach is that our BTS specification is actually quite comprehensive. And in this aspect, it is relatively unique worldwide. I don't think we have a similar width of regulation in any other such industry standard specification, which makes the whole thing, the whole document very attractive as a one-stop shop approach, which is expanded upon and in the review process which we are undergoing right now. Clearly, not every project needs every clause of the BTS specification, so it's quite appropriate just to simply mix and match. Take what you need and use it for your projects. And coming to that, this is perhaps one of the plenty of more overlooked clauses in our BTS specification because it sits in section 101, general notes, which nobody ever really reads. The specification is written in a modular form, and it's really intended that you pick it and you use what you need, and you add to that what you think needs adding for your specific project. And a very good example for that is obviously Transport for London with the T0006 specification, which follows exactly this approach and then returns a very useful standard specification for TfL projects, which is then further adopted to specific TfL projects. And I think personally that the popularity of the BTS specification worldwide results from this universality, because it's a comprehensive set of good practice in tunneling. It's really, really useful. You can pick it up, you can play with it. If you don't know how things exactly work, it definitely gives you at least a guideline on which to develop your own set of specifications. That's my take on the position of BTS spec, and now here let's just talk about what we have done with the new content over the last couple of years. Positioning for the future, and perhaps the first slightly provocative slide, why change? Because, well, we have a specification which is actually quite useful. We can modify it, so why change it? And I think it's the reason is not, we don't just have a technical progress going on around us, but society as a whole is progressing as well. And the landscape is evolving faster than we are oldsters like me are used to. Plenty of surprises going on, and I think we need to acknowledge this change, and we simply need to adopt the specification to retain an adequate amount of agency in this evolving landscape. To give you a couple of examples here, first, this is actually from the WTC this year, the welcoming address from Jenny Jan, our outgoing ITA president. And you see, first, drawing your attention to the title, Underground Solutions for a World in Change. And this was really the motto of, this was the motto, and this was also what I picked up at WTC. People were talking about change and were engaging in sustainability topics because it's at the forefront of people's minds. And people, I mean, not just the tunnelers, but our society as a whole, which are, at the end of the day, the people who pay our bills. Highlighted a couple of words in here, and you see the repetition. It's sustainability, it's innovations, it's greener, more environmentally friendly, more sustainable, and I think the last thing is the contributions of tunneling to sustainable development. I think this is the expectation of our clients, and we need to make sure that we deliver on that. The next practical example is the effect of the ongoing war in Ukraine on a lot of aspects on our lives. Clearly, the energy prices, it does not just affect our heating bill and our electricity bill, but also led to ArcelorMittal shutting down a blast furnace in Germany because it was simply not sustainable anymore. As many of you know, that shutting down a blast furnace is not just a flick the switch and it's off, and flick the switch again and it's on. This is a process which takes about half a year. So this is a very serious decision to go ahead with. So thinking about that, right, steel gets more expensive. This means reinforcement gets more expensive. Does this mean we're going back to plain concrete tunnel linings? Does this mean that macrosynthetic fibers get another chance? Will GRP finally become a useful reinforcement alternative for general cases? I don't know, but we'll see. The next slide, perhaps it's a bit of the wider picture. This is from the the Office of National Statistics of the United Kingdom, and it's a bit badly visible on the x-axis, but this is 2020. This is 2022. And you see what the index growth is just over the last 2 years. It's about 50%. This is construction material cost. I didn't break it down into whether this is concrete or steel or wood or whatever, but I think it shows the wide effect which we are seeing, not just from the energy crisis, but it's also the border disruptions from Brexit and the global raw material shortage which we're seeing. It's extreme. It's 50% price increase over 2 years. Crikey, that's a lot. And who would have foreseen that? I think nobody really would have foreseen the coincidence of a global pandemic and a major war in Europe at the same time, pretty much, or in sequence, and the effect. But still, it's not kind of a complete black swan event. It's risks. But then on the other hand, who would have seen it? Who would have foreseen it? And how can we really prepare for that? The solution from the Environment Agency is adapt or die. This is an official statement from a UK government agency at Congo, so not an official part of the state, released for the COP26 in 2021. I think we are, luckily as a tunnelers, we are quite experienced with changing conditions, whether in the ground or otherwise. So I think we can rise to this challenge. Now, perhaps going back to the slightly more local picture, what did we as our little technical subcommittee group do to adopt for sustainability? I have to admit, I mean, the headlines sound great: innovation friendly, carbon aware, welfare conscious, always learning. And but frankly, this is not how we started that. This is just sort of the headlines which I gave our activities after they have been completed. But I think they are true. And I'll give you a couple of examples on the next slides, which are now getting a bit more technical. I know you waited for that. Yeah, the first step, oops, here you go. The first step which we did when dealing with the updated specification in earnest was stepping back and really thinking about sustainability. We had a review on all the clauses in the BTS specification and assess them, okay, do they inhibit progress or not? Would they work in a sustainability-focused landscape or not? And I think the key culprit, which we identified at that point, was the fact that we had too many prescriptive clauses. And this is natural. If you design to concrete standards or to steel standards, you're used to that. Your concrete must do that, your steel must do that, and this is how you do it. But if you're then suddenly using a new material, how do you design for that in this context? And clearly, as clients are, how to say, I wouldn't say shy about new products and materials, but they rightly expect that whatever we offer to them delivers the same performance as the standard product. Luckily, the Eurocodes have a way to deal with that, which is the design by testing approach. Sounds like, well, how to say, a lot of effort, but I want to draw your attention to the fact that materials like steel fiber reinforced concrete, which are quite common and which are in use now for nearly 2 decades, are designed to according exactly these rules. There's no PSEN standard for steel fiber reinforced concrete. So ultimately, we're doing that. We're designing by testing with new materials already. We just need to extend this approach to other new materials, such as the graphene, for example, glass fiber reinforced plastic, macrosynthetic fibers, and the AACM, the alkali activated cementitious materials for concrete. We have not put detailed guidance for that into our specification because this is simply beyond the scope. We are looking to the industry to look into more detail for this aspect. And I think I'll leave it at that for this clause, but please keep that in mind. This is the single most important opening of the specification for new materials. Our general approach for existing materials was looking more into a performance-based design. So we have removed stuff like minimum dosages or a cement-type prescription from sprayed concrete. The 2R10 clause, the cement deals with sprayed concrete. Here you see, okay, it was 1, 2, 3, 4, 5 clauses just for cement. We had an industry workshop and decided, okay, we can do with one. Any competent supplier will be able to comply with the rest as well. We also included specifically carbon awareness. It's relatively difficult to deal with that because in the bigger scope of things, there is no fully developed regulation and no sort of mature standard you can fall back upon, which you can just dump into the code and say, look, everybody takes that and designs to this clauses and we're happy. The PAS 2080, which we referenced, is useful. It is used on major UK projects. It sketches out the responsibilities to manage carbon, but ultimately it's not prescriptive. It needs project-specific work. However, we are pointing our tunnel engineers, clients, manufacturers, the supply chain to the standard and encourage its use. It's the acronym you're finding here, the GHGs, greenhouse gases, really quantitatively accounting for them is really, really complex. We have, however, as I said, we put this PAS 2080 in. We're hoping that further guidance will develop along the lines, and we have at least prescribed that carbon management needs to be integrated into the project's QM system. I have a little intermediate summary for you here on sustainability, because obviously this was really the driver for the specification, and well, it is a time of change. We've seen that. I think regulation standardization must keep up. It's, from my point of view, lagging behind. We try to do our best with the BTS specification, but it's a very big topic, and perhaps the BTS is not the forum to set such rules. However, on the flip side, I think carbon footprint reduction as such, the techniques of those are quite well understood in the industry. It's just that it's not really enforced or, how to say, baseline on design. We don't have a baseline against which to measure a carbon reduction on a given project. It is in development. The industry is moving towards that, but fundamentally, our hands are to an extent tied. Nobody's really incentivized to save carbon on a current project because what are you benchmarking against? Coming back to some more, practical aspects of our specification. Staff welfare, health and safety, of course, we have referenced in the latest round of legislation and standard references, in particular the BS 6164 2019. Also, a new content here is our job-related competence assessment scheme, where we are indebted to the Transforming Tunneling Safety Group, which produced the SCATE matrix. The competence management as such is now a requirement in the specification. We encourage using the SCATE matrix. If something equivalent is provided, this is obviously also acceptable. However, we do not necessarily set the standards as such. We're not explaining the SCATE matrix, but we're referring to existing published information as far as practical here. A topic which is a bit closer to my daily work, precast concrete linings. I love them. Somebody else, some other people might love them as well, but it's really what I do every day. And here, the changes which we made might sound relatively minor, but I can tell you that they are have been driven by painful experiences in my daily work. Some of these might sound actually quite trivial, but we have clarified, for example, that compliance of a segment with the specification needs to be demonstrated on the segment, not on the mold, no, on the segment. It's harder than it sounds, actually. But then we also recognize that there are practical limitations to doing that. You can't measure everything on a segment in a practical way. Or some people can't, some projects can't, some can, some have the tools, but we need to retain the possibility of doing production control simply by hand. We have delivered on this aspect, and we have also integrated more clauses which basically clarify how production control can be undertaken. This is some people. I'm not sure if the people who are really cheering and clapping are now in the room, but this was the most desired change in the specification. Give us pictures to explain how the tolerances work. We have provided these pictures. We hope this is helpful for the industry. We will see how it goes. Quite likely there will be misinterpretation on the pictures then now instead of misinterpretation on the clauses. You never know. We'll see. At least we tried. One new aspect is the primary segment grout, and this is, I think, an interesting new topic. Of course, clearly since the last round of publication of the BTS spec in 2009, segment grout has come a long way. We've moved away from single-phase grouts. Most of the projects now use bi-component grouts. However, it's I'd say underspecified in the standard context. Luckily, somebody in Germany went through the effort of consolidating all the publications on WTC on primary segment grout and produced a specification for it now from the Deutsche Bahn Bill 853. We have assessed the specification. We are replicating key tests in our specification, and with this we try to standardize how to appraise grout, and this also leads to a better characterization of grout in the segment design. To set the special grout tests here sounds quite comprehensive, but this is pre-construction testing. We recognize that you can't really test, say, shear strength on a grout which is used on a TBM. Some more text on the primary segment grout. Clearly, the contractor shall propose a grout mix for the acceptance of the engineer. It's important that the ownership of the grout mix sits with the ultimate user. Driving a TBM, it's one system, and the system operator needs to be in control over the tools which he uses. The grout is in this context seen as a tool, not as a construction material. We have also introduced a clear split between the design requirements and specifications. And worth pointing out that we generally tried in the specification to retain its character as a material and workmanship specification and not to give too much design relevant input. However, here we have two clauses which are linking design, which is the minimum strength at minimum stiffness at first loading, and the maximum utilization of the grout. If you're interested in the detailed background behind that, meet me at the bar later. Another topic on segmental linings, we are staying with that because, as I said, it's close to my heart, but dowels. This is actually quite important because dowels have matured from a simple sort of positioning tool or something which keeps the gaskets clipped together into a structural design component. As designers, we regularly use the shear capacity of the dowels and the tensile capacity of the dowels to demonstrate ULS and SLS compliance of our segmental lining designs. But dowels as such are, in all honesty, really tricky to model in detail. If you pick up some finite element modeling and you want to model dowels, you're in for quite a journey. It's highly complex. Now, what does that mean for us? It basically means that we're having a ULS, SLS relevant material, which is not really well described, and where the safety case or the underlying safety approach is also not particularly well defined. So the BTS specification now calls for more specific testing of the product embedded in concrete if you need it in the design. Ultimately, we are hoping for a standardized approach, similar to what you're having to normal sort of drilled-in fixings, which are regulated through the ETA and CE testing, or an equivalent in the British standards context. That's already time for my summary on the technical content. It was over quick enough, wasn't it? Wasn't that hard? So we have tighter rules for some products, which we think is innovation friendly. We have looser rules for other projects, which you also think is innovation friendly. Obviously, the devil's in the detail, but I think we made good progress. You will be the arbiter to that. We keep our commitment to safe and sustainable working by referencing best practice and up-to-date legislation. And I think one thing which you also try to encourage is the early engagement between all stakeholders on a project. If you identify an issue, don't push it downstream, sort it out. An overview of the specification clauses. The BTS specification has now 73 sub-clauses in total. All 73 of those were reviewed. 43 of which have been updated, and we have 3 new sub-clauses. I think we were pretty busy the last couple of years. Now, who was actually busy? It was a collaborative effort with a lot of industry participation. Just putting some logos here on the screen. They are sponsors at the end, so they have earned some airtime. And this is also how this slide is intended to illustrate how the updating process worked. We have the BTS at the core of everything, which is, in this case, our technical subcommittee, which is 22 authors. Quite a lot. We reached out to more stakeholders in the industry. It's not just the BTS guys who write that, but we have specialist authors which we motivated to contribute. The wider industry engagement was done through workshops. We had one on spiked concrete, we had one on segment accessories, we had one on fiber reinforced concrete, which were well attended, 29 attendees, and followed by a peer review, which is now ongoing since July 2022. So far, at the time of writing this, we had 9 reviews coming in. I think it's more in the meantime. Likewise, I think we have breached a 200 comment milestone. This is already the last section. Time flies, doesn't it? The beer is coming ever closer. It's just outside, behind these doors. The route to publication and further engagement opportunities. Our roadmap. How do we finish with the specification? The key date, October 2023. This is where the finished product is supposed to hit the market. The said, our publication will be primarily digital. We have not decided yet whether a printed version will be offered. We'll see. Up to then, November 22 will be sort of the completion of the first phase of the peer review. We'll kick off the second phase, which of the peer review, I'll come to that on the next slide, which we want to finish January 2023. By March 2023, the whole thing goes to the publisher, which will be ICE Publishing. And we have then allowed another year for collecting feedback, and which will quite likely finish with publishing of an errata. Your opportunity engagement, if you're still willing and able, is from November 2022 onwards. We'll start in the peer review comments, which we have received so far, will be wrapped into the current draft to produce a second, I wouldn't say a second draft, it's not the final draft, but it's the second draft and pretty close to final, I guess. BTS members and, the way I put it, representatives in all entities engaged in tunneling are invited to review, but please send us an email by November the 7th. We'll review the applications and come back to you, and whether we can share the document with you for further peer review. This brings me already to my thank you slide from the BTS to all the contributors who worked with us and supported this document. For those of you who don't see your name here, sorry, I forgot you. You're entitled to complain later. Further thank you to all our predecessors supporting the BTS so far, and a big thank you to Kath Coldwell, without whom we would be really, really lost in the BTS. Thank you all for listening and for your attention, and maybe we have time for a couple of questions. Thank you.
Right. Are there any questions for Christoph, please? There are some roving mics. Please state your name and affiliation and then ask your question, please.
Donald Lamond, Hyperbaric and Tunnel Safety Limited. I've been around for quite a long time in civil engineering, and my first job in site was in the mid-1980s, when material costs were going up very rapidly, and we had the famous Baxter indices. And a contract was broken down into concrete, steel, timber, asphalt, various different materials, and each month an index of the price was published, and you did a sort of weighted average and applied that to the fixed rate in the contract. So perhaps with inflation as it is just now, we might be coming back to revisiting the Baxter Index principles.
Okay. What exactly was the question, Donald? I'm really sorry.
The question really was a statement. You said at the start that you'd not known material prices going up like this in the past. And I was just saying that obviously you weren't around in 1983 or thereabouts.
Okay.
But in the mid-1980s, there was a problem with material price inflation. And we had these indices which allowed you to apply a variation to the price of a fixed price contract.
Okay. Thank you.
Rosa Diez from MacDonald. You were talking about testing the new materials so you could design new materials based on testing, right? So who is to define this testing? Are we to trust the manufacturers to decide the type of testing that is required because they know the products? Or some of this testing is actually not standard either. They are not standardized. So how is the industry to follow what type of testing is required and how reliable they are?
I mean, it's a tricky problem, Rosa. I completely get where you're coming from. Well, ultimately, if we as designers or contractors propose a new material and as alternative to, say, concrete or steel, we need to demonstrate that it achieves the same performance as the material it substitutes. The one way which I showed is, this is, I think, also part of your observation. This is just one aspect of a new material. This is just a mechanical performance, which can be established with statistical methods based on the material parameters you rely upon in your design. There are other facets, like durability, for example, which equally needs to be captured. I'm not enough of an expert to say that. I think it's fundamentally the industry as a whole, which is the supply chain, which proposes these new materials, which will need to contribute to introducing the materials and making them a viable alternative to what we have right now. This said, quite likely this would benefit from some seeding money, which would come from somebody, the state, a major project, a big company, whoever. I don't have an answer, I'm afraid. I recognize there's a gap here, but well, we'll see what the future brings.
John Clark Hughes, Lower Thames Crossing for National Highways, and with Jacobs. Hopefully an easier question for you. I noticed in your extract there reference to the engineer in some of the clauses. I assume that the BTS specification is suitable for use with the NEC form of contract with some front-end drafting to make it compatible.
The role of the engineer is defined in the introduction to the specification. It's fundamentally, it's the person who can take engineering decisions. And this is from contract to contract, this is quite differently defined, and the BTS specification explicitly excludes this sort of detailed definition. It's not a contractual document. The engineer is the guy who calls the shots. And this is, I think, as far as the definition in BTS spec wants to go.
There you are, I told you it was easy. Thank you.
My pleasure.
Sorry, Christoph, me again. Okay. I can see from the presentation that the tendency is for the clauses to be quite generic. Isn't there a risk that this could lead to indifferent interpretations and therefore misinterpretations?
I mean, not all clauses are created equal. Some are more generic than others, I'd say. I had one slide up there which says we loosen some regulations, tighten some others. The loosening happened largely where the industry is relatively mature, such as for spray concrete, for example. The general idea is that we are moving from strictly prescriptive requirements to a performance requirement-based environment, where we as designers would say, okay, your spray concrete needs to achieve this, and that at this, and that age. How you do that, I don't care. I think this is, you can't do that if a spray concrete as such is a pretty novel material where you only have a limited amount of specialist knowledge in the industry. However, this day and age, after the massive project Crosswell actually was, which generated a real heap of very relevant learning, I think it's appropriate to be a bit more relaxed about these things. But you still have the opportunity in whatever project you're working to produce a tighter specification relevant to your project. Tighten up the clauses if you feel they don't really work for you. If the client is if it's sort of working abroad, the client doesn't have the same mature industry to hand. It's just a recommendation.
Hi Christoph, it's Chris Peaston here. I'm an independent consultant running my own consultancy. I particularly enjoyed the technical part of your presentation, thank you. Wasn't long enough for me.
Thank you.
I'm picking up on some of the things that our colleague over there has mentioned. I think you suggested that there weren't any European standards for fibre concretes at the moment, which of course is true, but there is the model code and there are the forthcoming adjustments to the European standards. It's difficult to write a contemporary document, but how have you referenced the information like that is coming in that domain?
I mean, personally, when I design with fibre reinforced concrete, I use the model code as well, but it's the model code. It's not an introduced standard in our standard environment. It's not a BS standard. So we are still not really designing to the Eurocode. But maybe we are designing to the principles of Eurocode with a capital P. I'm sure you know the differentiation in the code. I think it's a good illustration of, say, we take that for granted. Fibre reinforced concrete, oh, it does this, it does that. And we can do that because we have gathered a lot of experience based on full-scale testing, small-scale testing, project-specific testing over the last years. This observation was also intended to remove a bit of the, say, the shyness from using new materials. Because it's not that complicated to sketch out at least the mechanical parameters which you need to demonstrate, the rules to demonstrate equivalence. This is all in the code. It's there for us, pick it up, use it, and we would be code compliant. There's not that much R&D which needs to be done there on the mechanical side. I recognize Rosa's remark, sustainability, durability, completely different ballgame. This needs to be addressed by other experts. I can't answer on that aspect for durability for other concrete replacement materials.
That's great, thank you.
Neville Harrison retired. Probably I'm pleased I have retired, actually, seeing all the clauses that are coming up. But I wonder what is actually going to be the improvement in the finished articles with all these changes. My fear is that I can see costs going up.
Sorry, can you repeat the last one? What was your fear?
What are the improvements to the finished articles of when we finish the tunnels? But my fear is I can see the cost of the tunnelling going up.
Right. I don't think there's anything in the specification which necessarily drives up cost. The additional requirements, for example, on testing of, say, dowels, it is minuscule compared to even either the cost of the dowels as such or the cost of the dowels within the scope of a larger tunneling project. However, the opportunity it offers is you can get more out of the same product. By having the confidence what products can actually achieve in a practical situation and following a normative, basically the normative environment, the required safety, you can use them for a lot more things and perhaps do away with a bit of reinforcement here or a bit of material thickness there. We'll see. We don't think we don't have really stricter requirements for what the product has to comply with. We have perhaps stricter requirement of what you would what you should be checking before you use the product.
Dan Garrett, Nuclear Decommissioning Authority. Just wanted to go back over that steel fibre reinforced issue again. So just to give a bit of context, the Office for Nuclear Regulation, they produce their technical guides, and I'm sure many of you who've worked on things like Hinkley will be familiar with them. The technical guide turns around and says, well, in tunnelling construction and that particular sector, do what the BTS says, because they are the experts.
That's charming.
Yeah, it's nice, isn't it?
Yes.
It's nice to recognise that. So I wonder then, if the BTS spec makes a statement on SFRC, how that might impact the regulator's attitude. And given some of the, and I know there are confidential discussions on Sizewell C and Hinkley, given that, how to put it in a diplomatic way, civil service thing, given those difficulties in sort of understanding the impacts of adoption of this particular type of concrete, do you think there is a room or a space for regulator engagement in that discussion with the BTS spec?
I think, first of all, the fibre-reinforced concrete situation, at least the steel fibre-reinforced concrete situation, is transient, because with the next revision of the EC2 will contain rules for steel fibre-reinforced concrete. So we're looking at a temporary situation. I just wanted to show it because, well, we're nearly through that, and we haven't really bothered about the normative sort of ambiguity so far. We've muddled through successfully. It works a treat. Fibre-reinforced concrete is really working really, really well. But in summary, I don't think the BTS as such has either the ambition or the powers to set standards which are relevant for the UK or other markets. This is a specification. You can take it, or frankly, you can leave it. If you decide to baseline the specification for your contract, this is your conscious decision. We are making recommendations, what we consider to be best practice, but whether you want that is still up to the engineer.
Yeah, I think this is a sensible answer. It still comes down to the engineer to make the intelligent decision, and it is handy to know that that code is coming in, which would hopefully address some of those concerns. And I think it goes back to durability as well as a big concern over that. But that's a really great answer, thanks.
Mike King, independent consultant. I'm not going to ask a question, so relax. I don't know if this is going to help, but about the previous questions on fibre reinforced concrete, I just wanted to reiterate that this is a materials and workmanship specification and not a design guide. A lot of what we've been just discussing is our design related, and yes, we're all using the model, or most of us are using the model code. And there is another document that the BTS is working on related to steel fibre reinforced concrete, which will have a bit more in it about design. But the BTS spec is, as I've said it many, many times during the discussions we've had, this is a materials and workmanship document, not a design guide. So.
Yeah, I mean, on that, Mike, I'd just say, to a hammer, everything looks like a nail, and unfortunately, I'm a designer, so sorry.
Did you get that?
Okay. Have we got any more questions? Oh, yeah, one. Yep. That looks like Donald again.
Donald Lamont again. Just taking a slight issue with you on your comments about the BTS not involved in standards. There are numerous British standards, European standards, where quite a large proportion of the people who are helping from the UK perspective to write these standards are BTS members.
Yep.
And I think that I would take slight issue with you that the BTS should be involved in standards work, because there are many standards where the expertise lies in the BTS, just as for the specification, the expertise lies with the BTS. So I would certainly encourage people not to forget the standards route and to put the knowledge, the technical knowledge, into standards work. Comment, not question, sorry.
Yeah. Now, Donald, apologies for sort of this simplification which I made. What I wanted to say is that the BTS should not aspire to be a standard setting authority in its own right. There will be no BTS standard or whatsoever. It will be a British standard, a BS standard. We are not a standardizing authority. We are helping with standard writing, yes, definitely, and we see them grow, but we are not sort of the authority who guides, who sort of oversees them, their implementation, their adherence to, and their production.
Okay. If there's no more questions, thank you very much, Christoph, and for your presentation and for the work of yourself and the team. And we look forward to seeing the labour of your work at the end of next year when it's all published.
So do I, trust me. Thank you. Thanks, everyone.